All right, Matt, we're going to try this, see if this works. I don't know if you can see this or not, so we'll test it out. So we have several formulas we have to work with. There are two different concepts here. Number one, free fall. Anything that is falling due to gravity's acceleration, that's free fall. So when we look at our formulas, anything that has gravity in it, that has G, so both of these two down here at the bottom are free fall, as well as this A right here. That A acceleration is gravity because this is a vertical component, not a horizontal component. So this acceleration is not vertical, not horizontal, it's vertical. So this component is your free fall. V times T2, that is your deployed time. So once the parachute opens, the parachute controls the velocity. It doesn't accelerate anymore because the parachute is limited and stopped acceleration. It's still falling, but it's falling at a constant rate. So when we're looking for deployed anything, we have V and T, and height or distance is what we want from that. So if we think about normally, we would find velocity, right? Velocity is meters per second. And then time is seconds. When you multiply meters per second times seconds, that gives you distance. So really, D for parachute or deployed time, D equals V times T2. So this is for distance or height. This is for distance or height, but that's for free fall. The total height of the helicopter is free fall height plus deployed height. So add those two different heights together and you get the total height of the chopper. So let's see what we've got to work with here. We're going to need the two heights. That's what we'll add together for the helicopter. Free fall time, total time. Well, we can't do total time until we found out how long it takes for the deployed to work. So split it up into two different things, free fall and deployed. Now, they don't ask for deployed time, but we can figure out deployed time because we have deployed velocity and we have deployed height, right? So if we remember our formula, D equals V times T. So D, distance, deployed height, equals V times T. So to find T, I'd need to take deployed height divided by deployed velocity. So that would be something that I'm going to need to find total time. So we'll get to that in a second. Free fall distance. Can I figure out free fall distance? I got free fall distance, I got free fall time, I got helicopter height. So free fall distance. So the distance of free fall, if we look at our formulas again, the distance of free fall is this one here. So D equals 1/2 times G times T squared. So that's the formula I need to find distance of free fall. So D equals 1/2 GT squared. So I'm going to type those numbers in my calculator. Distance equals 1/2 gravity, so 9.81 times T squared. So that's time of free fall. I don't know my free fall time. So that's what I'm trying to solve for. So T squared is my variable in that problem. So my distance was 240.35 equals 1/2 9.81 times T squared. So far you would have 240.35, which is my free fall distance, equals 1/2 times 9.81 times T squared. And then we're solving for T squared. So I'm going to divide both sides. 240.35 divided by 9.81 and divide again by 0.5 or 1/2. So I get 49.00 is t squared. Most of them come out to a nice even root for time. So t is 7 seconds. So free fall time is 7.00. Make sure you put the 2 zeros there. Two decimal places. So that's free fall time. I can use my deployed height and my free fall distance, add that together, free fall distance, deployed height, add those together to get helicopter height. 240.35 plus 30.61 gives me 270.96. And then to find total time, this is where we go back over here, deployed height and deployed velocity. Deployed height was 30.61 divided by deployed velocity. That gives me a time, a number of seconds. No, wait a minute. Deployed height equals velocity times time. So to find time, yeah, divided by velocity. Sure, that's right. So my time here is 7.65 seconds. Sorry, the video cut me off. The time is going to be 7.65 from our deployed time plus 7 seconds from our free fall time for a total of 14.65 seconds. So hopefully walking through that example will help you get your bearings on this. If not, let me know and I'll go through something else.